Number 5, predict. The index of refraction indicates how fast light can travel through a medium. The higher the index is for a medium, the slower light will travel through that medium. How do you think increasing a medium's index of refraction might affect the angle of refraction? So, if we know that light travels slower through a medium with a higher index, how do we think an increased index would affect the angle of refraction? Make a prediction, write that down for number 5. Number 6, gather data. Keep the index of refraction 1 set to 1. Set the angle to find the angle of refraction and the change in direction. So, we're going to reset. We need our index of refraction 1 set at 1, which it is. We need the angle of incidence at 60 degrees. And now we're going to change the index of refraction 2 based on what it tells us to do in the table. So our first one, we need our index of refraction 2 to be set to 1. Again, we adjust our protractor. We end up with an angle measure of 59.89, which will round up to 60 degrees. So our angle of refraction for number 1 is 60 degrees. Well, our original angle of incidence was 60 degrees, so there's no change, or 0 degrees. Now we need to change our index of refraction 2 to 2. And 6th graders, just for context, when we're looking at 2 different medium here, hey, imagine that for an example would be like light traveling through air in medium 1, and then that light wave hitting water in medium 2. Okay? So when we say medium, it's just 2 different things that our light wave would be traveling through. Okay, so we have our index of refraction set 2 set to 2. Let's see what happens. We adjust our protractor, and we end up with an angle measure of 25.3, which again, for ease of math, we'll round down to 25. So our second angle of refraction is 25 degrees. And when we do 60 minus 25, we end up with a change in direction of 35 degrees. And for our final one in this table, we need to set our index of refraction 2 to 3. Adjust our protractor. And we end up with an angle measure of 16.65 degrees, which we'll round up to 17. So our angle of refraction for our third one is going to be 17 degrees. And when we do 60 minus 17, we end up with a difference, or a change in direction, of 43 degrees. Now, number 7, analyze. What patterns do you notice? Again, we need to look at that table we just filled out. So what we were changing was the index of refraction 2, and it was getting bigger. So as the index of refraction in our second medium got bigger, how did that affect the angle of refraction, and how did that affect the change in direction? What patterns do you notice in the table above? Number 8, explain. Why does no refraction occur when the media have the same index of refraction? So, when we did our first trial here, both of our mediums had the same index of refraction, and we had no change. Why do you think that is? We are officially on to number 9, explore. Set the index of refraction 2 to 1, set the angle of incidence to 25 degrees, collect data for each index of refraction 1 listed in the table below. So we need our index of refraction 2 set to 1. We need our angle of incidence set to 25. And for our first one, we need our index of refraction 1 set to 1.5. Adjust our protractor. Sometimes it can be a little tricky trying to get in the middle. There we go. We end up with an angle measure of 39.02, which we will round down to 39. So our first angle of refraction for number 9 is 39 degrees. So now to find our change in direction, we need to subtract our original angle of incidence, which is 25, from 39. And we get a change in direction of 14 degrees. That was tough. Nice mental math, Mr. Maynard. Now we need to set our index of refraction 1 to 2. Play again. And we get an angle measure of 57.53, which we are going to round up to 58. So our angle of refraction for our second one is 58 degrees. We're going to do 58 minus 25 to get our change in direction. $58 minus 25, we get a change in direction of 33 degrees. And for our final one, we change our index of refraction 1 to 3. We're going to hit play. Ooh. Something very interesting happened there. So we need to adjust our protractor. And we end up with an angle measure 24.25 degrees. So we're going to round that down to 24. So our final angle of refraction is 24 degrees, which gives us a change in direction of 1 degree. Number 10. Analyze. What did you notice about the change in direction in the first 2 trials? So looking at our first 2 trials in the table above, again, what did we notice about the angle of refraction and the change in direction? And then, what happened in the third trial? So the third trial was a little different. Okay, what happened there? When the angle of refraction is greater than 90 degrees, the beam of light will reflect off of the surface instead of refracting through the surface. This is called total internal reflection. 6th graders, you have just completed your final online lab at distance learning. Very well done. Round of applause here from Mr. Maynard. And as always, you stay classy, Stewartville. Go Tigers.